I apologize. We didn't have it last week. We had a bunch of remote team members come into Redmond, Washington from Texas and Atlanta, and a lot of the younger staff too. So they haven't had the campus experience. So we were having a team offsite. So that's what we were up to. But can you guys see my screen?
Yep.
Cool. So I didn't send notes the last time because it was such a short call, but I did take notes. And so we're on our 106th meeting today, and that's a lot. I had the items in the queue. Hold on, Carter, be quiet. So these were the notes last time where, you know, Ashutosh and Marion had filed a few PRs, and Riff presented his virtual, was it a virtual KVM, or basically the virtual switch idea. And then Riff was working on the Flow API document. And then Murcha may run the baby hero test in the future, run it on the behavioral model. So we were looking for comments into 532. And that was really all that happened last time. Rick, did you get the comments you were looking for in 532?
Let me check.
I can check here. So this is
Yep.
the DAS HA session. Yeah. So we have
Oh yeah,
Maureen.
I
Mhm.
think all the comments right now we have has been addressed.
Mhm.
If there is no more comment, I think I'm waiting for Marion to check the one last thing because he had some questions around the HA set even callback.
Mhm.
So yeah, that's a one last comment, I think. But
Okay.
yeah,
So
once that
that's
is done,
here.
we can decide.
So we're waiting for Marianne comment. Okay. Sounds good. And then I can't see, I'm only on one screen today. Do we have Murcha on the call? Let's have a look. I don't see Murcha. So that's fine. I can check with him about running BMV2. But I did notice that there were quite a few pull requests added here, the metering HLD. And did you want to touch on that, Riff? Or I guess we can read it. Go ahead, I'm sorry.
Yeah, if like because those three I actually sent out the three updates like FLD updates. So those three are mostly like very just towards the very dedicated like scenarios. So I can actually walk through them like one by one, but it's a preview version. It's probably not fully finalized yet.
Yeah.
Yeah,
Do you want to look
probably
at it next week or something?
next week probably will be like finalized, but if I'm not really expecting too much of a changes, and if we have time today, we can walk through them, just to gather like the the feedbacks or comments, see if I made anything like silly over there. So yeah, I think it is good.
Okay. So did you say you wanted to cover it today, or you walk through it today, or no?
If I have time today, sure.
Yeah.
I can
Yeah.
briefly walk through them. Yeah.
Okay. Do you want to present, or do you want me to present on the screen here?
Yeah, I can present.
You can present? Okay, then I'll
Yeah.
stop real quick. Okay.
Okay.
Yeah, I'd love to hear more about this one.
Yeah. Oh, it's been a while didn't see the PRs, so. um, okay, can anyone see my screen now?
Yeah.
Okay, perfect. So basically, we have like three PRs. One for the PrivLink, PrivLink and the PureLink NSG. Another one for the flow simulation. The third one is for the metering. So I walk through them one by one. So first one is the PrivLink NSG. So basically,
excuse me, but I don't see anything being shared. Is there somebody sharing something?
Yeah.
I'm presenting the screen. Yeah.
Yeah.
Oh, I see. Thank you.
Thank you. So the first one is a private link NSG. Is there anyone else that cannot see the screen? If there is, I can like probably retry.
I think all the rest of us can see.
Okay, sounds perfect. So first of all, it is a preview version. It's not finalized yet. Just
Sure.
like the making sure everyone understands this one again. So some changes may be needed like in the next week. So if any other changes like coming up, we can like go through them again. So and this is just for like the getting the early stage of the feedback comments, because things are missing. So just in case. All right. So first of all is a private link NSG, and in this one, it is basically used for, of course, private link. I'll skip the background. The SDO transformation. So this is a VM to private link. Okay. So so from the VM to private link, this is what we have as outbound direction. So the VM will coming from the the packet will coming from the VM, and it will be looking like this one. So it will be sent to the smart switch or the dash pipeline with the destination sent to the as you can see here is the data plan bit with the internal packet as IPv4 packet. Then the smart switch will steer the packet to the dash pipeline using the destination VIP or in the source MAC. So once you find the ENI, then it process the packet, send it out, and the outbound packet, the outgoing packet will have the GRE in cap with the private link key, and all these the destination sends to the private link service, and the source will set the smart switch one, depends on the policy. In the packet will be IPv4, so it is IPv6 to IPv4 to IPv6 NAT, so it changes to the IPv6. And the how the IP gets changed is also depends on the policy. All right. So when the return packet comes, so from the POS to the VM, and it just like reverse. So we'll see like the packet. For example, here is still the NVGRE in cap, but with the source and destination swapped. IPv6 is the same swapped, and also the MAC address from the source MAC will change to the destination MAC. The return side back to the VM is essentially also the same, like everything swapped. Oh, this one is a typo. I will fix that. And then in the packet is IPv4, so we need to change the IPv6 back to the IPv4, and the IP is also swapped, as we can see here. Right.
Hey, Riff, a quick question. In the return path, is the VNI still outbound VNI?
The return
I'm just
path,
trying to
the
remember
VNI
this.
is, the return path, the VNI is still the outbound VNI when talking to the VM, and the return packet from the POS is still the POS key, the private
Okay,
key.
that the key will be representing the VNI.
Yeah. So both sides will use its own key, but no matter which direction of the traffic.
Thanks.
Yeah. All right. So private link energy will be slightly different. It will be on top of this packet, on top of the outgoing packet. It will have extra tunnel, that's tunnels to the NSG. So, and we can see the NSG here, which will go through the policy later. All right. And then the return packet, in the PLNG case, the return packet will be exactly the same as PL to VM, because it bypasses the NSG and just directly goes to the smart switch for packet processing. So that's why the incoming tunnel doesn't have the NSG in cap here. All right. So that is a PLNSG. And so for in the PR and PLNSG, how it works with the FastPass is that here the FastPass is not, of course, it's not the express route FastPass. This one is the flow redirection we have in the dash for the load balancer. And when the when the flow redirection packet, when we receive the fastpath packet and then changes flow, once that is changed, then in the non-PL NSG case, so in the PL case, what happens is that we will change the flow directly points instead of like points to the private link service, will directly points to the VM. So that is for the flow direction. And if PLNSG is used, then we'll remove the outer in cap. So the outer in cap will be gone, leaving only the inner in cap, and the destination points to the VM directly. So that is how the fastpath is getting used here. All right, and then
Sorry, just I didn't get the last point. So for the PL-NSG case, after fastpath, you will remove the NSG encapsulation, and will you also remove the private link encapsulation, so it will go directly to VM?
It will rewrite the change the private link.
Oh, okay.
So you with the destination points to the VM.
So
you basically the inner in cap will pretty much
Okay.
follows whatever the fastpath we are currently doing right now.
Okay, so it will change basically everything to VM to VM. Okay, so okay.
It basically follows the current fastpath design.
Yeah, can you just change the ER to express route? When I was reading it, wasn't clear to me what
sure.
ER means. Yeah.
Oh,
Or maybe there's yes, there.
Okay. Oh, I can change that. Yeah, I can change.
Okay, thanks.
Yep, no problem at all. So then some certain features is not required. For example, the reset on idle timeout. So this one is not required. All right. Then next one is scaling requirement. So as we can see, we still have certain things to be done. So once it is there, we'll get it published. Yep, and basically the scaling requirements follows exactly the same as what we already have in the dash as the dash scaling requirements. The number of fastpath packets also follows the fastpath design, so it is exactly the same thing. Reliability requirements, this one just follows, for example, the new flows when it is created, it needs to follow the HA design to replicate the flow to the other side. So nothing too special here. All right, then let's talk about the SciPI designs. Okay, so first of all, in the ENI attribute, in the ENI, we will add we actually already have the PL underlay SIP, which is used for setting the underlay IP, which is essentially this IP here, the source IP here. And then on the mapping, so on the CAPM mapping, then what we have is that we already have all the attribute for setting the setting the overlay. So what we don't have right now is that because the IPv4 to IPv6 change, it is essentially a prefix. So that's the thing we don't have right now, is that we don't have a SIP and DIP mask. So we'll add a SIP and DIP mask in there to making sure like you can work with overlay SIP and overlay DIP to form the prefix. That's how the Sci represents IP prefixes in the So and additionally, because of the PLNSG is there, so we need to add a tunnel ID then to specify the tunnels. And another thing that is different from the current dash design is that the PL link and PL link NSG, they will share the exactly the same routing type. Then how do we know which one will get used? Like when it is a PLNSG, when it is PL, how it gets used is then the tunnel ID. So as long as the tunnel ID is set, we will add the tunnel, which completes the PLNSG scenario. So there is no extra routing type gets introduced here. I probably missed the routing type. I'll add that later. Okay. So then once the tunnel ID is set, we need to have a way to specify the tunnel. So the tunnel table pretty much follows the SCI next hop design. So it basically has two tables. The first table is a tunnel table, then it specifies the entire tunnel. For example, what VNIs we use, what encapsulation that we use. The second table will be the next hop table. It will specify the tunnel ID and the diff. So in this case, it will be something like this. All right. So that's pretty much the all the SCI APIs will get introduced here. And then for the pipeline behavior, let's go through the real scenario and with all the policies to see how everything works. Okay, so starting from the VM to PRs.
So can I interrupt you and ask a couple of questions before that? Sorry about that, right? So the underlay SIP, right? So is an attribute of the ENI, I understand that. But in the diagram, you're also showing the switch, the smart switch IP, right? So when do you use smart switch IP versus a different IP per ENI? I mean, from a use case point of view, do you have use cases where instead of using the smart switch IP, you will use a separate IP per ENI?
So basically, there are two places that will change the IP. So the first one depends on policy. So it doesn't really matter. Like here we have the 2.2.2.1. So whatever the address we have here, there is no implicit way that we say, okay, we're just going to use this address. Whichever the address we're going to use will be specified in the policy. That means that the two places. The first one is of course coming from the mappings or routings. We'll go through like later. The next one is actually the ENI. The ENI will also have the, it depends on the scenario. It could have like PL underlay SIP, or it can have like underlay IP for the ENI. For the ENI. So depending on the scenario, it will be whichever one that specified over there. So there is no implicit saying, oh, we're going to use this IP. So it's coming from the policy. Yeah.
But I was trying to figure out is that I mean, when you say policy, right? From a use case point of view, why would you change one or the other? Why would you pick one or the other? I'm just trying to understand that use case.
Oh, I see. So in certain cases, let's say we want to talk to the private link service that locates in other regions, in other regions, or we may want to use like different IPs. So that's basically it. So certain cases we want to change the IPs. That's why the IPs could be different.
But if you do that, right, when the return traffic comes, will it still land at the same DPU?
Yeah, it's just the BGP. As long as we announce the IP, it will land over here. So that's
okay. So you can announce all these multiple IPs from the smart switch, and any of them will land up there. Okay, got it. Okay.
Right.
All right. Yeah.
Yep.
Yeah. Okay. Thank you.
Yep. No problem at all. All right. Then let's go through the policy and pipeline. So the first one is a VM to private link direction. So this is the outbound direction. The outbound direction. So let's say we have a VM. So all the data here then is following the graph like here. So but I don't know how to put it like side by side. But anyway, so if you have the I'll send it to the chat. If you have it opened, you can actually have it side by side to see how it works. All right. So starting from the private link, and we'll cover the return paths later. So starting from the VM to private link direction, and also starting from private link. Then the first one is the direction lookup. So how direction lookup happens today is that we use the VNI. So depends on the VNI, we'll set, because it's coming from the VM, it has outbound VNI. So it will treat the action, and action will say, oh, it is outbound action. Then it goes to make the packet go through the outbound pipeline. Then after the VNI lookup, it will be the ENI lookup. So in the ENI, we'll check the Ethernet MAC, then is set with a MAC address, and also it will give us the ENI ID. That will be the ENI side object ID of the ENI. And from the ENID, then we can basically look up the ENI, and in this ENI, we'll get the PL underlay SIP. So this one points to 2.2.2.1. All right, and then we'll go to the flow table. Because it's the first flow, if the flow really exists, we'll apply all the transforms. If it doesn't for the first flow, then we move on. Echoes, there's no change in the echoes. Whatever echo sets, we'll just walk past it, so we'll skip this part. Routing. Then next phase is doing a route entry match. So we'll use the inner destination MAC or over the MAC. This is IPv4 MAC. IPv4 address, not a MAC. I mean IPv4 IP. Then we'll use this one to find the route entry, and this will trigger. Eventually gets VNet, the VNet routing type, then goes into the map routing action. Then basically goes to the mapping stage. In the routing stage, we'll have a few attributes set. For example, this is pretty much the action with the VNet action. Then we'll have the destination VNet ID set. We can also have the metering class set here. All right, and then goes to the mapping. The metering class will have a slight update. We'll go through them in the metering HLD. So this one published first, so I haven't get a chance to update this one. So I'll update this one later. Then the metering. Then we go to the mapping stage, and this one will check the CAPM mapping. So from the CAPM mapping, what happens is that we already know the VNet. So this is the entry key. So we have the VNet, we have the destination IP, and then once we the lookup result will give us the all the attributes that here. For example, in here we will get the private link mapping, and no matter it is private link or private link energy, it shares the same action. And then we'll get the underlay diff, all the overlay information, like doing the 46 transformation. As we can see here, the SIP and SIP mask here will be working together as IP prefix. And also, it can override the metering class, depends on where the destination gets sent to. Right. Then the next one is the metering. The metering will be like taking the metering class, update the metering, find the metering bucket, and because we already have the metering class set, we will not use the metering policy. So that's basically the metering stage. Then after this one, all the information that we need to create a flow is basically there. So we'll use that to create a flow, change the packet, and then we update the metering bucket using the metering class we have, and send the packet up. So that's basically the private link. For private link NSG, the only thing that's different is actually the tunnel. So basically on the CAPM mapping, we'll have the tunnel ID set here. It will share the same routing type. That means that whenever the tunnel ID is set, we'll add the tunnel. So from the tunnel table, we have the encapsulation. Then it is set to the VXLAN because as we can see here. Then on the VNI, it will use whatever the VNI we have. I just put a random VNI here, just an example. And then the next hop will be the tunnel ID, and this one is basically when we create a tunnel, next hop we need to know like which tunnel is actually associated. So we need a tunnel ID as here. Basically, it's how the SciAPI next group member is the same design, just follows the same design. So in this case, if we need any other attributes in the tunnel, we can always add it. So then other things, the most important thing is to set the diff. Then we can set the energy IP. All right. So then it's basically from the VM to PRS. And then next one is the return packet, which is the PRS to VM direction. So in this direction, there's pretty much no policy. So whatever we have is that we will already have a flow that will contain the reverse set of the transformation from the IPv6 to IPv4. So we'll just use the use a flow to handle the packet. And in the same metering class, so metering update will follow the same thing, update the same exactly same metering bucket as a VM to POS direction, as the outbound direction, and outbound routing just for the packet log. Database schema will get sent updated in the Sonic dash HLD. So this one, pretty Sunny will work on that as a separate PR. So I'll skip this part as that, but it pretty much just follows whatever the attributes we had here. All right. So that's pretty much everything for the PR and PLNSG. And if no more questions, I will move to the flow simulation.
Okay.
Okay, cool. Then the next part is the flow simulation. So this part is the metering is the most the simplest part. So I'll still do this part first. Okay. So actually let me think a little bit. Let's do the metering first because we just talked about the metering, right? So while everyone remembers, let's go to the metering. Yeah, and this one is actually fairly straightforward. There are certain changes, but it's fairly straightforward. The first one is that we will have the metering is mostly for bidding purpose. So it's not for like debugging, or it's not for. Oh yeah, Christina, please. I see you raise your hand.
Are we talking about metering per card or per E&I right now?
Yep. Well, we'll go through the resource modeling. Then
Thank you. I'm sorry.
Yep.
Thank you.
Yeah, no problem at all. Yeah. Thank you. And then the metering is mostly for bidding. So it's not for like debugging. It's not for like the just regular counters we show up somewhere else. It's just dedicated for bidding purpose. Okay, so it's not for like traffic policer or shaping. So that's a thing. Yeah, that's a big background. Then how the metering gets modeled, it's pretty much still the same as what we have in the dash right now, but it will be a little bit simplified because as we can see, we have removed all these like the priority and overrides, all these like the complicated schema. So it's very straightforward how it works now. So we'll use a different mechanism to replace the existing one. So how the resource gets modeled is that still every ENI, it is an ENI level metering bucket. So every ENI will allocate a set of a metering bucket for bidding purpose. The metering bucket will indexed by a uint 16 number that we call metering class. So it is starting from 1, and the 0 will be reserved and considered as not there. So if it ends up with 0, then no metering bucket will be updated. There is no so-called like metering bucket 0 as a bucket. So yeah, and then each metering bucket will contain 1 inbound, 1 outbound, and for counting at least bytes. We only count bytes right now for bidding purpose. Then this is the same as what we have today. And then the requirement for the metering is that it is actually needs to reflect the traffic volume of the real traffic volume of the customer. That means it only counts the overlay packet. Whatever the the underlay packet we have, like the encapsulation we have, we will count it. And then on the outbound direction, it needs to count before the SDN transformation. For example, in private link, I'll take the private link as example. Let's go to not this one. This one. Yeah, there we go. So it will count the overlay packet and before the transformation. So it counts IPv4 one. And in the inbound side, it should count the packet after the transformation, which means then it counts the packet after the transformation, which is also IPv4. The IPv6 packet will be, the size will be different, but that is whatever the change that we are doing in the SDN, so it should not be counted as a customer's traffic. So that will be different. Yeah. The scaling requirement, as we can see, there's still one to be done. So we'll get that updated later. So whenever it is ready, so it will take some time. And then the metering bucket will have like right now it is 4K. So 0 is considered as not set, so it's actually like 4K minus 1. Yeah, and then reliability requirement, of course, is that in the HA setup after switchover happens, the bidding still needs to continue to work. So yeah, that's pretty much the same. Right. Okay, and then for the SAI API design, so this one is that instead of what we have right now in the meter on the ENI is, or how to describe the metering bucket is that on the ENI we have the oh, I think we don't have this one. I'll remove this one, but yeah. Oh, sorry. This is actually a typo. So in the ENI, it is sorry, on every ENI, what we have is that we have two attributes. One is that the metering policy for the V4. This is where the typo is. The metering policy V4 and the metering policy V6 on each ENI to specify that, and then to specify the metering bucket. Oh, sorry. This is the metering bucket. This is literally the metering bucket. So every metering bucket will attach to one ENI, of course, and it will have the metering class describe what the metering bucket, which metering bucket it is. Sorry, yeah. And then to get the packet out, so today Dash is using the attribute directly on the metering bucket, and then that is not really matched to what SAI is currently doing. So how usually SAI does is that it's either count ID or it is the stats. So then we have all the infrastructure that already lives in like Sonic community to get the stats. For example, like the get or get reset or this different schema. We also have like timely put, like infrastructure already there. So we can basically reuse all the things by just changing it to the stats. So then we chat about that and says, okay, the stats is actually a more proper way to get the packet, get the data instead of using the attributes directly attached to the metering bucket. And then on each metering, on each policy, instead of having just the metering class, as we can see in the other one, we have the metering class here. We will change that to metering all and metering and. And with these two, we'll use the metering all and metering and to replace the priority and all these like override like behaviors. Okay, so it basically updates the all bits and end bits, and yeah, it will contain on the routes, contain on the mapping, contain on the tunnel, and on the inbound side for the inbound, it will have it on the inbound router rule, which is although it's called a router rule, but it's based on it is a VNI lookup. So it is looking at the VNI, and for each VNI, we'll have different metering all and metering end. All right, and then the global metering policy is basically the exactly same. So it is on the ENI level, we have the metering V4 and metering V6. Yeah, on the metering policy, yeah, that's a IP address family, yeah, for IPv4 and IPv6. Okay, and the metering rule, exactly same thing. There's no change in there, so I'll skip that now. And so then let's walk through how the pipeline actually works. So the pipeline, how it works will be much simpler than what we have today, because we don't have the overrides or these like the toggles over there now. So what we're doing is that we have two values. The first one is aggregated metering all and aggregated metering end. So they're both zeros with unit max. Sorry, the all is 0, the end is unit max. And then what happens is that if we hit the flow, then we'll use whatever the metering class stored in the flow, of course. And then after the flow, if we hit any of the policies, for example, we go to the routing stage, then we'll hit the router entry. The router entry will have its own metering all and metering end. So we'll take that and aggregate them separately as a like all, just use all bitwise all to do that, and end is a bitwise end to get the final end. And after all the policies get matched, for example, in the mapping, we'll get a probably different one, and the mapping may contain a tunnel. In the tunnel, we'll get a different one. So whichever one we get, we'll just add on top of that and get the final one. And then, after the final policy gets matched, then we'll get the final one by using the OR bits and do a bitwise AND to the AND bit. So we'll get the metering class over here. So how this works is then, okay, if we have certain cases where the OR, for example, the mapping has said something, but eventually we say, oh, even though this mapping gets hit, but it actually sends to something there because, for example, like peer VNet or whatever the case is, and in that case we'll have the metering class AND, and the AND bits can be used to override the mapping bits, depends on the use cases, and this is how this works. So then after this, we pretty much get the final metering class. We from all the policy entries, and then if the final metering class is still 0, so we will start to use the metering policy. So instead of like having the metering policy enabled bits, we'll say, okay, if it's not set, then we need to use metering policy. That's pretty much it. And then we'll go through the IPv4 and IPv6, depends on the original overlay packet. And then from the IP, and this is slightly more specific. So it's that in the outbound pipeline, we'll use the destination IP. In the inbound pipeline, we'll use the source IP to do the ternary match and find the policy rule. Find the metering rule. And from the metering rule, it will get the metering class here. And then that will be the final metering class. Then we'll use that to update the meter bucket. And then if still we get 0, then as we just chatted, no metering bucket will be updated. So that's pretty much how the pipeline works. So while going through the thing, while going through the metering HLD, I think that two things come up into my mind. Probably this is also something we can talk about. Is that although the requirement says it is only 4K, but sometimes we probably support more than 4K, or sometimes depending on scenario, is that because we have 64 ENIs on the card, and we may say, okay, in certain cases we just want depends on the future. If we want like huge ENI, then just like, for example, like one single card, and then we'll have more the more metering bucket. And in this case, then uint 16 may not be enough. So in that case, I think probably change it to uint 32 will be more future proof. But yeah, that's pretty much it. And also depends on how much each implementation can support. Maybe we can add a capability to say, okay, how much we can actually support, and we'll just use whatever we have. Yeah, please, Christina.
Do you think we'll ever see a case where we just have one ENI consuming a whole card?
Oh, no, not really. I'm just totally, because I'm just doing some math calculations. It's not really having a real use case like that. But it's really,
you never know. Yeah.
Yeah, you never know. Yeah, and that's why that if you calculate the number of metering bucket that we can support is already exceeding the uint 16, which makes the uint 16 a little bit probably not
efficient.
That ideal. Yeah. So probably change it to uint 32 will be easier or more feature proof. The other thing for capability is the same, is that okay, because as you can see, when we do the initialization, we need to actually call the SciAPI to create every single metering bucket, but we'll create like 0 to 4,000. But well, maybe sometimes things could happen, depending on the scenario. It's probably not really good to have a hard-coded number in the code. So a more proper way will be getting the how much supported from the capability, and then use whatever we needed. Or if it's not like it's not supported, then we say, oh, it's not supported. We can give the more efficient error messages, so we know what is actually happening. So that's pretty much the two things we probably didn't have it in the HLD right now. And if it looks good, I will add it over there. Okay. So that is basically the meeting.
Do
Yeah,
you want to save FlowResim for next week or,
Chris,
you wanna go
I have
over
a
it now?
question
because
about
we are
metering.
right over time.
oh, go ahead,
yeah.
metering question first,
Yeah,
sorry.
Marian, yeah, please, sorry.
Yeah, so there is a metering design also in the Sonic HLD. Are you going to completely remove it? Is it
Number
still
3,
need?
I was gonna say, is that 313? Because I was thinking the same thing.
Yeah,
Yeah.
So for the Sonic Dash HLD, so then one Prince will update the then HLD with like the database schema. Yeah, so then we'll come up with a different PR. So
I'll put it in the chat window, Ref,
Yep.
just so you can see it. Yeah. Is this the one you meant, Marianne? Put in the chat window. There we go. Did you
yeah,
want
this was the metering design that came in last fall sometime, right? Summer,
Mhm.
fall, I guess.
Yeah, yeah. So if we could like combine the two or figure out what we're gonna do with both. Yeah.
So then one will be updated later by.
Okay.
So at
Okay.
the minimum, right, Ref, if you have 4K metering buckets per ENI, and if you have 32 of them, so 128K is essentially the minimum limit or a minimum requirement here for any implementation, really.
For 128K.
Or
Sorry, I'm probably slow in the math.
32 times whatever 4K is what I'm thinking.
Yeah. Because I'm thinking the 664 ENI, so it is 200.
Okay, that's 256K, yeah.
Yeah, but anyway, it is exceeding this number, so yeah.
Ashutosh, go ahead.
Yeah, Ashutosh, please.
Yeah, Ref, so I'm a bit curious on this bitwise and OR operations, right? Is that how you will expose this to your Azure customers, like, or they express their requirements in a different format and you translate it to the and OR masks?
So the metering class, it is how it works is, and it's not like directly because the customer cannot change the metering class. So how it works is that the customer can create VMs or whatever service inside of Azure, like in any way they want, and it depends on where which service they talk to from which VM, it will be charged like different. So that's why the metering class is there, because for different locations, they need to be like metered like different. This is how the metering. This is why we have like different metering class, and it's also not associated or tied to every single mappings, because it's not for debugging. It is basically every single metering bucket is that they can be metered like differently or charged differently. So yeah.
Okay, so if you're going through multiple services, for example, you can set multiple beds and
Right.
and do things like that to basically
Right.
aggregate the cost of those. Okay, got it.
Yes.
Thanks.
Yep. Thank you.
So do we want to cover FlowResim next time, maybe, Ref?
Yeah, because we are at 45, so I think we can get go through this one like next time.
Okay.
And you'll have all the because for flow simulation, the majority of the things and how it actually works. So this one will take a little while. So
Yeah, okay. Is it okay if I steal the share back?
oh yeah, of course.
Okay,
Yeah,
so
sorry about that.
this is awesome. Thank you. This looks like a ton of work that you wrote there. So hopefully, oh, sorry, I have on my screen, this is the former one that I put in the chat window, Ref, just FYI. Yeah. Cool. And then I did see in the PR.
The roadmap group, I will look at
Yeah.
it if Marian thinks it is
Yeah.
ready to.
So
review.
I did see this one come through just the Psi group, not specifically Dash, but I thought it was interesting to put in here. We're just moving the tunnel decap. So saw that one come through. And then here you said something about the routing groups. I'm sorry.
Yeah, there are two PRs, the routing group and I think
do we need to add you as a you're already a review? Do you want to be a reviewer on this one? Okay.
yes.
Okay.
So I will
cool.
review this one, and there is another one like Ashutosh is doing for fixing the VNet test cases.
Mhm,
So I'll
mhm.
review that one as
Yeah.
well.
Okay.
Yeah, because probably need a little bit of time because
Oh, yeah.
Ashutosh actually commented out all the config underlay. So I'm just
Mhm,
checking
mhm.
like what
Yeah, sure, sure.
what things would
I-
happen. Yeah,
I appreciate the work, Ashutosh and Marian. Thank
Yep.
you.
thank you.
Yeah, and I know that Mircha joined a little bit later, but Mircha, are you still planning to run the baby here on BMV2 at some point?
Yes, we are still
Okay.
working on that.
Okay, great. So that's great. What time is it? It's 9:50. I want to open it up to the rest of you guys. Do you guys have anything you want to cover today? Since we've gone through these docs? No? Okay. Then I'd like to give a little time back, if you don't mind, just to prep for your next meetings or whatever, if that's okay with you. And I will make sure and write meeting notes this week, like I said, and that's about all I have. Is that okay?
Thank
Yeah.
you.
Yeah? Okay. Thanks, everybody. Appreciate your time. And
Thank you.
I will
Thank
see you
you.
next time.